Hello guys, welcome back. Today I have again some questions from the Allen Score test series. So basically this is the first question. Okay, I will also write this is a multiple correct. Okay, multiple correct question. So give yourselves a try and then I will solve this. Okay, so now I will start solving. So basically we have a differential equation and we have to solve that and look into the options. So I will write this down. This is x f dash x plus x tan of x plus 1 into f of x equal to secant x. So basically if I divide this complete equation by x, I'm writing this as dy by dx. And this thing will become tan x plus 1 by x. And this is y, which is equal to secant x by x. So basically you guys can see that this is a linear differential equation. So basically we'll try to find out the integrating constant. So basically our integrating factor for this differential equation will be e power integral tan x plus 1 by x dx. So this is pretty simple to integrate. This will come out to be e power. Okay, this is not integral. This is a ln. I'm not putting mod because x is positive, I guess. X is, I guess, bounded between 0 to pi by 2. I will write it down. This is 0 to pi by 2. So basically I'm not putting mod in ln mod sec, and this thing is plus ln x. So what we can do is, I will, as this is in product form, I will bring it as ln x secant x, and this is base e, so this will come out to be, okay, this is not ln, it is e power ln, so this will become x secant x. So basically y multiplied by integrating constant x secant x, this will come out to be integral of the RHS is secant x by x multiplied by x secant x dx. So basically x and x get cancelled, and this is integral secant square x, which we know is tan x. So basically our final differential equation, I mean the equation after solving this differential equation, will be yx secant x equal to tan x plus c. And now I will just look at the question once. So basically they have given us a condition that f of pi by 4 equal to 0 to calculate this integrating constant. So I will do it. So as f of pi by 4 is 0, so basically this thing is 0 because y is 0. Tan of pi by 4 is 1 plus c, so basically c is minus 1. So our equation comes out to be yx secant x equal to tan x minus 1. We are not done yet, we have to now observe the options. So what I will do is I will take this to the RHS. So y equal to tan x minus 1 divided by x secant x. Now if we break this into 1 by cos and this as sin x by cos x, so basically our numerator becomes sin x minus cos x, and 1 cos x from here will go up and this cos from here will come down, so they will get cancelled. Finally we are left with this. So basically I will write it. So basically our final equation comes out to be y equal to sin x minus cos x by x. So now I guess it's time to look at the options. So in the first place we have to find out f of pi by 3. This is f of x. So basically f of pi by 3 is, pi by 3 is 60, so sin 60 is root 3 by 2, cos 60 is half, and this is again pi by 3. So this I guess comes out to be as 3 times root 3 minus 1, and this comes down, so it's a by 2 pi, which is I guess correct. So option A becomes correct. So we will go to option B. So basically our option B tells that we have to actually check whether f of x equal to 1 has a solution or not. So basically if we put f of x here, this is sin x minus cos x equal to x. Now, if we divide this thing, I mean multiply this thing with root 2, this will come out to be 1 by root 2 sine x minus 1 by root 2 cos x, which I'm writing as root 2 times sine of x minus pi by 4. And this is equal to x. So basically we have to draw the graphs and compare. I will try to draw it out for you guys. Say this is our coordinate axis and this is the line y equal to x. Let's say somewhere here this is your pi by 2 comma pi by 2. And now we have to draw root 2 times x minus pi by 4. So basically this, it's obvious from this part that this will be below the x-axis, and the nature of it will be somewhat because the ascending part of sine curve is this. So basically I guess we will require only the ascending part, because if we try to ascertain this, just a minute, in this particular curve basically pi by 2 will come somewhere here, and this part is actually starting below. I will draw it here completely. This is something of the sort what it will look like. So basically if you can see, these two curves never meet. In whichever way you draw this curve, it will never meet. This is your pi by 2, and this is basically pi by 2 minus pi by 4, which is root sine of pi by 4. So basically it is root pi by root 2 into sine pi by 4 is 1 by root 2. So this is 1. So basically at pi by 2, this is pi by 2 comma 2. Now pi by 2 is approximately 1 point something. This is, if we find 3.14 by 2, this is basically I guess 1.57. So this is 1.57. I'm just taking these values for your reference, you don't need to do. And this particular point, I guess this will be 1. So this is roughly the graph. Anyways, we don't have any intersections between these two curves, so your option B gets wrong. There is no solution to this sin x minus cos x equal to x. So now we move on to the next part. So in the part C, basically we have to find out an area. They have given us a function g of x, which is x times f of x. So basically x times f of x will be, this was sin x minus cos x divided by x was f of x. So basically g of x will become sin x minus cos x. So we have to, I guess, integrate this from limits pi by 4 to pi by 2. G of x dx, which is integral pi by 4 to pi by 2 sin x minus cos x dx. I'm not doing this integration. This is like, it will waste my time for calculation. You can do this, or what you can do is you can also approach the graphical solution if you want. Like, I will just give a short glimpse of what you can do. You can draw the sine curve like this. Cos curve passes approximately something like this, and if you notice, this is pi by 4 I guess, and somewhere this is I guess pi by 2. Okay, my graph is not so accurate. This will actually come something like this, because at pi by 2 it is 0, so the cos curve will pass through this place. Okay, you can draw it. I guess my drawing is not so good. So what you can do is this sin x minus cos x, you can either convert this into, what you can also do, one thing, you can convert into something like this form, root 2 sine of x minus pi by 4, draw its curve, and then you will actually get it pretty easily. Or what you can do is you can trace it from here also, the sin x minus cos x part, like remove from sin x, you can remove the area that is coming within cos x curve and then find out. Or otherwise, I guess, don't go into complexity. For exam hall you can directly calculate. The value of this will actually come out to be root 2 minus 1. Please do the calculation, guys. I'm leaving it. So I guess our option C is correct. This was option C. And in option D, we had that this g of x function, this is basically a bounded function. Now g of x is sin x minus cos x, which is our root 2 sine of x minus pi by 4, as we found here, the same thing. So sine this particular thing has a range of -1 to 1, right? So root 2 multiplied will give it as minus root 2 to root 2. Okay, this is closed. I'm sorry. This thing is closed. So yeah, it is like bounded function means that if this thing had no defined range, like say if we had a range for this function 2 to infinity, then we could say it is unbounded, but here it is perfectly bounded, definite. So option D is also correct. So basically our correct options for this first question will be A, C and D. This was a good question. Now, please note, I guess I took about 9 minutes to solve this on board here, but you guys have to do this in the exam hall in approximately 5 minutes. This is not like very complex stuff to explain. I did it slowly, but in the exam hall, when you have pen and paper, you can do this pretty easily because even the differential equation was very easy. It was nothing complex. Okay, guys, so I will proceed to the next question now. So here is our next question from coordinate geometry. Basically, this is on radical axis and number of common tangents. This is an easy question. You can try it out if you want. So I will start off. Basically, our first circle is x squared plus y squared minus 8x equal to 0. And our second circle is x squared plus y squared plus 2x equal to 0. Now to find the number of common tangents, what you in the exam hall, what you can do is if you want, you can draw the like diagram graph for this. Although I will draw the circles and the diagram, but in exam hall, if you don't want to go with drawing and stuff, you can easily like find out C1, C2 and R1, R2, not R1 plus R2. You can find out C1, C2 and R1, R2 individually, and after that you will understand whether we have to do R1 plus R2 or mod of R1 minus R2. So basically, if we look at this particular question, in case of S1 circle, the center is 4, comma 0. This is your 2g, our f is 0 here, so basically it's minus g. And from here it is minus 1, comma 0. So if this is your C1, this is your C2, our C1, C2 distance will come out to be as 5. And if you observe for R1, our R1 will basically I guess come out to be 4 itself because it's centered at 4 comma 0 and it's also passing through the origin, and R2 will come out to be as 1. So as you can see from here, if we calculate R1 plus R2, this is 5. So basically our C1 C2 is equal to R1 plus R2, which basically explains that these two circles are perfectly externally touching. They are externally touching at one particular point. So if you just draw a rough diagram like this for two externally this is touching, okay, this is not intersecting. For two externally touching circles, there are two possible tangents only, which makes our option A automatically correct. Okay, it's not two possible, I'm sorry. It's actually three. This is also another. So basically option A is correct. The number of common tangents is 1, 2 and 3. This one passes through the intersection point. This tangent is basically called the direct common tangent. This is common to both. Okay. So you have, I guess, read DCT and TCT. So after this, they have said that the radical axis of S1 and S2 is x equal to 3. So what I will do is I will actually draw the diagram for you guys. You will easily understand. So here is an approximate diagram. This is the y-axis. This is the x-axis. Okay, guys, please note that this is actually a straight line, but because of lack of space, this is the point P where actually it intersects. This is also a straight line. The diagram has become clumsy here. I'm sorry. So this one is a straight line. Okay, please note. This is just for your understanding. So basically, this is our required triangle PQR, and this is the circumcircle to PQR. Now, what we can observe from here, we can observe certain things. Okay, I will try to name this as some PA and PB, so it will be easier to write. Let this point be B and let this point be A. So basically, as you can observe from here, that PA by PB is basically our 1 by 4. This is PA by PB. I guess this is pretty obvious. So basically, as you can see that P is dividing the line segment AB externally in the ratio 1:4. So I guess it is pretty easy to find out P. It will become 1 into 4, and this is, I guess, minus 4 into minus 1. I'm writing this as plus 1 divided by 4 plus 1. And this is, I guess, both are zeros. So anyways, this will be 0. So this comes out to be minus 8 by 3 comma 0. So here is our point P. And as you can see, it was written that x equal to 3 here will be our radical axis, which is completely wrong because x equal to 3 is coming somewhere here. It is inside this circle. So our, I guess this was option B. Option B is completely wrong. And in option C and option D, we were required to find out the equation of the circumcircle of triangle PQR. So now, as you can see, this particular circle, we have the P point with us. So I guess we can easily find out. Okay, just a minute, guys. Please note here, I am really sorry. There was a mistake in my circumcircle basically. As you know, if you know from the properties, this particular triangle PQR will actually, this circumcircle will actually also pass through point A, okay, which is this is, I guess, the circle S2, and this was S1. So basically, I will write down here also for your understanding. The circumcircle of triangle PQR passes through the point A, or what we had written as C2, whatever you consider it as. So it passes through minus 1 comma 0. So basically minus 1 comma 0 and minus 8 by 3 comma 0, these are the two diametric points of the circumcircle. So now we can apply the diameter form of circle to find out the equation. So it's basically x minus x1 times x minus x2 plus y minus y1 times y minus y2 equal to 0. So this will be x minus of minus 8 by 3, this is just plus 8 by 3. X minus of minus 1, which is plus 1, plus y minus 0 into y minus 0 is y squared. This is equal to 0. So basically we have x square from here. I'm writing the y square. And this thing is 8 by 3x from here, and there from here we will have another x. So 8 by 3 plus 1 is 11 by 3 into x plus 8 by 3 equal to 0. This is our final equation for a circumcircle of triangle PQR, which is, I guess, in option number C. So automatically option D gets wrong because it was also the equation of circumcircle, but it is wrong. So this is it. Basically our E and C are correct. This was a good question on the fundamentals. I will proceed to the next question now. So here is our next question. This question is actually a replica of a JEE Advanced PYQ which was asked long back. I mean, not exactly, but the options looked somewhat similar. Something like this, I remember this has come in JEE Advanced basically. If you look at the PYQs, I guess you will get it. Anyways, so basically if you want, you can try. I'm starting off. So this is a function which is defined from all real to 0 comma 1, and this is a continuous function basically, which is worth noting. Now we have to say which of the following functions have the value 0 at some point in the interval 0 comma 1. So basically, indirectly, if we say if this is 0 and this is 1, we have to find out, we can express this statement in many languages. Like either we can say that we have to ascertain whether this particular curve is changing sign between 0 and 1 or not, or whether this particular curve is crossing 0 or 1 or not, is any value between 0 or 1 or not, or if it has a root between 0 and 1. It has many, you can express this in many ways as you want. So now let's study each question carefully. So what I will do is I will take each of these options, the functions given in these options, as g of x. So whenever I write any particular option and then g of x equal to, please understand that it is the function that is given in that particular question or that option. So first we go with option A. Here it is gx equal to x power 10 minus f of 2x. So if we find out g of 0, this is minus f of 0, and now f is from all real numbers to 0 comma 1, so basically f of any x is always positive. So g of 0 becomes negative, and g of 1 is coming out to be 1 minus of f of 2. So basically whatever this is, g0 into g of 1 is basically less than 0. Because if you notice, I guess this thing will be positive, which is very obvious because the values are always between 0 to 1 and 1 is open. So this will come out to be some 0.00 something, but it is obviously greater than 0. So the sign of g0 into g1 is less than 0, which basically means that it is passing through a particular point. It is changing sign in between 0 and 1, and for that it has to pass through the x-axis on any value that is located in between 0 and 1. So alright, our option A becomes correct from here. I will proceed to the next option. So for our option number B, we have gx as, I guess, x square minus integral 0 to x f of t dt. So if we try to find out g dash x, this will come out to be 2x minus of f of x. Now if you put 0 here, basically 0, but this is obviously 0, and integral 0 to 0 will also be 0, so g of 0 is 0. So 0 is a limit. I mean 0 is a root of gx. And if you observe g of 1, then this thing will be, I guess, 1 minus integral 0 to 1 f of t dt, which is obviously greater than 0, right? So g of 0 into g of 1 is 0, and we actually don't need this also. You can find it out anyways. If we draw 0 and 1, so basically this thing is passing through 0, as g of 0 is 0 and g of 1 is somewhere here greater than 0. So the curve will go something like this. It is not passing through any more values in between 0 and 1. So basically our option B becomes not correct. For option number C, next we have g of x equal to, I guess I will write this within brackets. This is integral 0 to pi by 2 minus x f of 3t sine of 6t dt minus x. So basically if you observe, so for this particular thing, actually if you find out a g of 1, this will be less than 0. I'm telling how. And g of 0 will be 0. So basically what you can do is either you can find out g dash x and also do, or what you can do is you can break this thing as a sine. This is sine of 60, so you can basically break it as a 2 sine 3t cos 3t, and then you can make a substitution for sine 3t, say it is u. So our du will, I guess, become minus sine okay, I will write this down, sine 3t as u. So if we differentiate this, this will become 1 by 3 cos 3t dt as du. And after that, if you like substitute the limits, I guess it will come out to be 0 to 1. And then you can easily solve. You will find out basically g of 0 is 0 and g of 1 is less than 0. I'm not doing this. This is a pretty simple integral. And you can keep f of 3t as, if you want, you can keep it as a constant, or as t is inside, you can, what you can do is you can substitute, initially you can substitute 3t as some z. So basically this will become f of z sine 2z, and 3 dt will be dz. So in place of dz you can write 1 by 3 here. Whichever way you do this, you will get this result. I'm not doing this because this is simple stuff. So because g of 0 is 0 and g of 1 is less than 0, so if you observe the curve, g of 0 is a root, this comes like this, and g of 1 is somewhere here, say, so it has to pass like this. So basically there is a place between 0 and 1 where it passes through, so our option C also will become correct. If you try to solve this, if you guys can't solve this, then please let me know in the comments. I will post the solution for this in my posts section. So now we will analyze option D. So basically our option D is g of x equal to, it was root under x cube, I am writing this as x power 3 by 2, minus integral 0 to, I guess, x, and this was cube root f of t dt as far as I remember. Yeah. So if you observe g of 0, it is automatically 0. No questions. This is 0 and this is 0. And if you try to find out g of 1, it will become some 1 minus 2 by 3 lambda power 3 by 2. Something of this. Or what you can do is, no need to find g of 1 actually. We will make it complicated. Just differentiate this equation g dash x. You will get 3 by 2 x power of 3 by 2 minus 1, which is half, and this is minus cube root of f of x dx, or rather dx is gone, I'm sorry, no dx. This is cube root of f of x. So basically g dash x is always greater than 0 because this is x power half and this is cube root of f of x, so their difference will be positive. I guess you can understand why. So if we observe g of x, it is never 0. Just a minute. So basically as g dash x is always greater than 0, so g of x will never be 0 in 0 to 1, right? Pretty obvious. This is like, I guess, the second, I guess the second case. Exactly like the second case. 0 is a root here and g dash x is greater than 0. This will go like this. It will never intersect any point here, okay? This is passing through 0, please don't mistake the diagram. So basically, I guess the correct options for this question will be are A and C. This was a good question. And please, if you guys don't like, you cannot solve, I guess this is pretty simple stuff. This is a very simple integral that you can solve. If you don't like, you face any difficulty while solving this and you don't know, you can actually refer to me in the comment section. I will make a post and explain how to do this. So yeah, we will proceed to the next question. So here is our next question. After a long time, we have a question on graph transformation. So it is pretty obvious. What you can also, like, if you want, you can check all those conditions. Like you can do the endpoint checking. You can do root under 1 minus x square. So basically 1 minus x square greater than 0. And but because in the third one there is a multiple number of mods, so in my opinion, I guess you should do it using graphs because you guys know graph transformation, right? So I will draw the graph for this. So basically the other two, one is a straight line and the other is a semicircle. So you can draw those, but this thing is a bit complex. So I will, because we haven't encountered graph transformation questions still, I will try to demonstrate this to you guys. So basically what we will do is we will first start from here. Mod x is inside most. So we know the graph of mod x, it is something like this. This is y equal to mod x. Now mod x minus 1, so it is basically shifted 1 unit downwards. So this will be mod x minus 1. Doing it step by step, okay? Please observe. Now mod x minus 1 whole mod. So basically the parts this and this which are below the x-axis will go upwards. So this will be, it will be like this. This point is this was point minus 1. So basically this is point 1. This is minus 1, this is 1. This is our mod of mod x minus 1. So after mod of mod x minus 1, we have again decreased one height. So this will go to the origin. This part will go to the origin. So this graph will come 1 unit downwards. So I guess this will become something like this. This is our mod of x minus 1. I mean mod of x minus 1 whole mod minus 1. Moving from here, now we have one final mod, and I guess this is the final mod if I observe. Yeah, this is the final mod. So if we take this entire thing and put this in a mod, basically what we will have will be something like this. Basically we will have two hills. So this is, I guess, your origin, and let me observe once. I guess this is 2, this is 1, this is -1, and this is -2. Although we will not actually need this part of the graph, but I drew the whole thing so that you guys can see. This is your final graph for this part. So now if we try to draw the graph for this particular question, this will be a bit big. Yeah. So our first was from minus infinity less equal to x less equal to 1. It was y equal to 2x plus 2. It passes through -1 and y equal to 2. So if we take -1 here, basically this will be something like this, straight line. And because it was less equal to 1, so we can give a bold dot. Now from, I guess in the next part, from -1 to 1 both open, we had the circle, I mean upper part of the circle, x square plus y squared equal to 1. So basically this will be like this. This is the circle, this is your 1. Now acha, this is okay, please note this thing is open. Okay, for the next part we will have our mod of this particular graph. So as you can see, this is where it will begin from basically. So on both sides it is basically closed. So this hill here is actually the bold dot I am drawing. This will come like this on 2, and it goes till infinity. So basically this is our graph for the question. So as you can see, the graph has an empty part here. So g of x is basically, the graph is broken. So it is discontinuous at x equal to 1. And it is non-differentiable. I will check, I guess, at, we will see the sharp corners. Okay, so x equal to, I guess, at -1 there is a sharp corner because it's going like this, sharp corner here, -1. At 1 it is not continuous, so it is not differentiable. You guys know, like if at a particular point, if it is not continuous, it will also not be differentiable. And also at 2 there is a sharp corner. So basically this is the conclusion that we reach from. I will read the options once to find out which are correct. So our option A says that g of x is non-differentiable at exactly 3 points, which is correct. Option B says that g of x is continuous in between -infinity to 1, which is obviously wrong. I hope you can understand, because here's the graph, it is hidden. At 1 the graph was breaking. Okay, so this is incorrect. And C, g of x is differentiable in between -infinity to -1. Yeah, this is correct, because it is only the straight line till that, and -1 is also closed. So you can't say that it has a sharp corner there. -1 is not closed, it is open. So you can't say that this is not differentiable. C is also correct. And D says that g of x has a discontinuity at x equal to 1 but is continuous at x equal to -1. Yeah, it is correct. So basically our options here are A, C, D. The correct option. This was also an easy question. We will proceed to the next question now. So here is our next question. So basically we have two square matrices A and B of order 3, and we have to check all these options and say which are correct. This is an easy question. So in option number A, it says A, B, A transpose is a symmetric matrix. So we will try to find A, B, A transpose, whole transpose. So there will be it's called the reversal law. So from here we will write this is A transpose whole transpose A. then B transpose, and finally again A transpose. So basically these are not equal, so option A is incorrect. It's not symmetric. In our option B, we have AB minus BA is a skew symmetric matrix. So again, AB minus BA whole transpose we have to find. So this thing will be AB transpose minus of BA transpose. So again we apply the reversal law. This is B transpose A transpose minus A transpose B transpose. So yeah, again this thing will be incorrect. I guess you can understand. AB minus BA is not skew symmetric. This had to be minus of AB minus BA, so that is nowhere I can see. In option number C, we have B equals to modulus A into A inverse, and it's clearly written mod A is not equal to 0. It's written because so that we can actually write A inverse as adjoint A by modulus A. So small hints are actually given in the questions. Okay, you see this and you immediately realize that mod A will be somehow in the denominator, and that is when we change A inverse as adjoint A by modulus A. So this gets cancelled. So basically our B is adjoint A. Now we have to check whether adjoint of A transpose minus B is skew symmetric. So adjoint of A transpose minus B is basically adjoint of A transpose minus, we can write B as adjoint of A. So yeah, I guess if we take the transpose of this thing, okay, I will write this in another step. Adjoint of A transpose minus adjoint of A. Although it's pretty visible actually, but I will still write whole transpose. This will become individual transpose. So adjoint of A minus adjoint of A transpose, which we can write as minus of adjoint of A transpose minus adjoint of A. So basically, which proves that this thing is skew symmetric. So I guess our option C will be correct. And I'm doing option D here. In our option D, we have B plus A transpose as 0, or basically null matrix, you can say. Now what we have is, it's given that A is a skew symmetric matrix. So A transpose is given as minus A. This was given. So if we write from this part, this is BA equal to minus of A transpose, and what we will do is we will basically take B power 15 equal to A power 15. I hope you can understand why. Because basically their mods are same, so B power 15 is A power 15. And now as A is skew symmetric, so A, as you know, A is skew symmetric, so A power any odd, that is of the form like 2n minus 1, A power any odd number will also be skew symmetric. If it was even, it could have been symmetric, but here it is odd. So basically I took 15. You can take any odd value that you want. Although they have actually given 15, so better to take 15 here. So basically A power 15 will be skew symmetric. So obviously B power 15 is also skew symmetric. So yeah, D is also correct. This was a simple question, so our correct answers for this question is, I guess, C and D. Now we will proceed to the next question. So here's our next question. I guess this will be the final question for this video. So basically we have to find out the number of positive integral solutions for a product form. So now as we have all this xy and x plus y, what we will do is we will try to bring only these numbers and their consequent powers. The powers might change, but we will only keep the RHS in terms of numbers. Otherwise it's difficult to ascertain the number of positive integral solutions. So what I will do is I will write the question first. This is xy equals to 2 cube 3 power 4 5 power 6 times x plus y. So basically let's take this thing to be some, say, lambda. then xy minus lambda x minus lambda y will be 0. So what I will do is basically to add this thing to both sides, I will add lambda square on both sides. Now you will ask why I added lambda square. I could have also added lambda. I added lambda square basically to write this thing as x minus lambda into y minus lambda. I hope you can understand. And we had this as lambda, so lambda square will be 2 power 6, 3 power 8, and I guess 5 power 12. Now you can easily write this as some capital X and capital Y, which is equal to 2 power x 6 into 3 power 8 into 5 power 12. Lambda doesn't matter actually. This is capital X into capital Y. So now we are actually prepared to find out the number of positive integral solutions. So say it is given as capital N. So basically our capital N will be, I guess you guys know this. We have a list of formulas like to find out number of common divisors and all that. So from there, this is 6 plus 1, 8 plus 1 and 12 plus 1. If you guys want a detailed video on permutations and combinations and various questions, because permutations and combinations is a chapter from which this year also JEE Advanced has given very good questions. So if you want a video on that, I will try to bring that sometime later. You can write down in the comment section. So basically this will become 7 into 9 into 13. Now this is 9 7 is 63. And 13 3s is 69. We have 6. 13 6 are 72 plus 6 is, I guess, okay, just a minute. Okay, I did a mistake. 13 3 is 39. This is 13 6 is 78. I'm sorry. And 7 plus, I guess this will come out to be as 819. So basically we don't have to find this, we have to find n by 91. So this will be 809 by 91, which is basically 9. So our answer for this question will be 9. This was simple, like from the fundamentals part. So this will be the final question for today, guys. I will bring out more questions in the next videos. So do like, share and subscribe, and thanks for watching.